So I had given you a problem x of n is equal to 2 power n into u of minus n. So I told you to solve it, right? So to find energy or power of the signal. So before trying to solve this problem, you have to identify whether it's energy signal or power signal. Okay, so we'll try to plot it graphically and we'll come to conclusion whether it's energy signal or power signal, and we'll try solving it. Okay. So x of n is equal to 2 power n into u of minus n. What is u of minus n? Guys, what's u of minus n? What is u of
minus 1?
What is u of n? What is u of minus n? U of n is discrete time unit step signal. Correct? You have to know these basics, okay, for solving. So it will exist from 0 up to infinity. Up to n is equal to infinity, it will exist with an amplitude 1. Okay? From n is equal to 0 up to infinity, this signal will exist with an amplitude 1. What is u of minus n? So u
0 to up to minus infinity.
Yeah, correct. So u of n is time reversed version of u of n. Okay. So u of minus n will exist from 0 up to minus infinity for negative values of n. N is equal to minus 1, n is equal to minus 2, minus 3, minus 4, minus 5, so on up to infinity with an amplitude 1. Clear, everyone?
Yes, ma'am.
Clear? So
Yes,
your question is x of n is equal to 2 power n into u of n. So give values for n and find out how will the signal look, x of n. Okay. So 2 power n into u of minus n. U of minus n is existing from minus infinity to 0. Correct. This signal is existing from minus infinity to 0. Fine. Whereas u of n exists from 0 up to infinity. Okay, u of n is equal to 1 for n for n greater than or equal to 0. It is 0 for n less than 0. Whereas u of minus n definition is, it is 1 for n less than or equal to 0. It is 0 for n greater than 0. Clear?
Yes, ma'am.
Okay, this is a definition of unit step, discrete time unit step signal. Okay, so we have been given a question, x of n is equal to 2 to the power of n into u of minus n. Okay, so give values for this. This signal, this x of n exists from minus infinity to 0. That you have to understand from this. Okay, so now give values for n. Okay, if n is equal to 0, 2 power 0 into 1. What do you get?
1.
1. If n is equal to minus 1, 2 power minus 1 into 1, what do you get?
0.5.
Half or 0.5. Okay. If n is equal to minus 2, we are giving values, negative values of n. Because it's u of minus n multiplied with u of minus n, the signal will not exist for positive values of n. The signal will exist only for negative values of n. Okay, the signal will exist from minus infinity to 0. So I'm giving values from n is equal to 0, n is equal to minus 1, minus 2, so on. Okay, so if n is equal to minus 2, you have 2 power minus 2 into 1, which is nothing but 1 by 4 or 0.25. Okay. If n is equal to minus 3, you have 2 power minus 3 into 1, which is nothing but 1 by 8. Okay, so on. So we'll try to plot this signal. 2 power n into u of minus n. Okay. So x of n is equal to 2 power n into u of minus n. Okay. So first, at n is equal to 0, the amplitude was 1. At n is equal to minus 1, the amplitude was half. Okay. At n is equal to minus 2, the amplitude was 1 by 4. At n is equal to minus 3, the amplitude was 1 by 8. At n is equal to minus 4, the amplitude will be 1 by 16. So what type of signal is this? It's a non-periodic signal, correct? Yes or no? The amplitude is decreasing.
Ma'am.
Anyone has a doubt? So this amplitude is decreasing. So it's a non-periodic signal. So we have to find energy of such signal. Okay, find energy. What is the formula for energy for discrete time signal? Tell me the formula for energy for discrete time signal.
Summation n is equal to infinity to minus infinity in
Yeah, summation.
x of n whole square.
Yeah, energy equation is for discrete time signal, it is summation n is equal to minus infinity to infinity x of n modulus of x of n whole square. This is the equation for energy of discrete time signal. But our signal is existing from where to where? This signal.
Minus infinity to 0.
Yeah, it's existing from n is equal to minus infinity to 0. Okay, so this is 2 power n into u of minus n. I'll take it as 1 because amplitude is 1 whole square. Okay, so I'll interchange the summation limits. Okay, in integration, if you interchange the limits of summation, you have to multiply it with a negative sign. But in summation, if you interchange the limits, you need not multiply with negative sign. Just you can interchange it. Okay. So you have n is equal to 0 to minus infinity. So I'll take it as 2 power 2 to the power of n. Okay. Because I want to get it in the form of GP. That is nothing but summation of n is equal to 0 to infinity. Alpha to the power of n is equal to 1 by 1 minus alpha. This is the equation for geometric progression, right? So I'll always try to get it in this form because it's easy for me to solve it. Okay. So what is the limits now? I have n is equal to 0 to minus infinity and I have 4 to the power of n. But in this equation, I have n is equal to 0 to infinity. But in my equation, I have n is equal to 0 to minus infinity. What should I do? This is not same. These two are not same. I have limits n is equal to 0 to minus infinity here, whereas in geometric progression equation, I have n is equal to 0, summation n is equal to 0 up to infinity. So what should we do? We have to make that minus infinity as infinity. How do we make that?
Summation 0 to infinity.
Yeah, we have to make 0 to infinity. So how do we make that?
Ma'am, taking n as negative, ma'am.
Yes, we take n is equal to minus n. Okay. So now your summation n is equal to 0 to infinity. So what happens here? 4 to the power of minus n. Okay. So this 4 power minus n, can I write it as 1 by 4 to the power of n? So you have summation n is equal to 0 to infinity. This 4 power minus n, I will write it as 1 by 4 to the power of n. Now did I achieve this in the form of GP? Did I get it into this form? N is equal to 0 to infinity. Alpha to the power of n is 1 by 1 minus alpha. I've got it to this form, right? Clear, everyone?
Yes, ma'am.
So now you solve it. It is in the form of alpha to the power of n. So the next step would be 1 by 1 minus 1 by 4. So what do you get? It's 4 by 3 joules. Clear, everyone? Is it clear?
Yes, ma'am.
I will just brief up once again. Okay. So we have been given a signal 2 power n into u of minus n. Okay. So u of n is a discrete time signal, discrete time unit step signal, which exists from 0 up to infinity, u of n. Okay. Whereas u of minus n is time reversed version. Okay. Or folding or reflection version. Okay. We have seen what is time reversal, right? It is folding about y-axis or vertical axis, right? So this is just time reversed version of u of n. Okay. So u of minus n is time reversed version of u of n. Fine. So u of minus n means the signal will be mirror image of u of n, right? So the signal will be present from minus infinity to 0. This is the definition of u of minus n. It is 1 for n less than or equal to 0. It is 0 for n greater than 0. Fine. So this is the definition of u of minus n. So we know what is u of minus n now, and x of n is equal to 2 power n into u of n. So from this we have to understand that if they give you u of n or u of minus n, you have to understand that from where to where the signal will exist. That is your x of n. Okay, from this u of minus n, we understand that x of n exists from minus infinity to 0. Fine. So now we shall graphically try to interpret this 2 power n into u of minus n. How will it look graphically? So if we give values for that n, so if n is equal to 0, you have 2 power 0 into 1. Amplitude of u of n is 1, right? From 0 to infinity, amplitude of u of n is 1. So I have written 1 here. So 2 power 0 is 1. 2 power at n is equal to minus 1. 2 power minus 1 into 1 is half. Okay. Whereas at n is equal to 2, 2 power minus 2 into 1 is 0.25. Okay. At n is equal to 2, it's 1 by 4 or 0.25. At n is equal to 3, you have 2 power minus 3 and you have 1 by 8. At n is equal to minus 4, you have 2 power minus 4. Okay. And you have 1 by 16. It goes on. Okay. So it is a diminishing signal. It's a non-periodic signal. So we have to find energy of such signals. So energy of discrete time signal is given as summation n is equal to minus infinity to infinity modulus of x of n whole square. Okay. So we understood that our signal will exist from minus infinity to 0. Here it's 2 power n into u of minus n. Amplitude of u of minus n is 1. So I've written 1 here. So put our limits. So we have minus infinity to 0. So in this summation, we can interchange the limits. Okay. Whereas in integration, if you interchange the limits in integration, you have to multiply with a negative sign. But in summation, you can interchange the limits without multiplying with any negative sign. Okay. You're free to change the limits. So I have just reversed the limits here. I have put n is equal to 0 to minus infinity. Because I had from minus infinity to 0, I have put from 0 to minus infinity. I have changed the limits. In summation, we are free to change the limits. Okay. So, and I have put 2 square to the power of n here. Okay. So, what we have, summation n is equal to 0 to minus infinity, 4 to the power of n we have. So, our geometric progression equation is summation n is equal to 0 to infinity alpha to the power of n. Okay. But our summation is minus infinity here. So to make it positive, to get it to this form, I'll multiply n with, or I'll replace n with minus n. Okay. If I replace n with minus n, summation n would be 0 to infinity, 4 to the power of minus n. Okay. So I'll take 1 to the power of 4, 1 by 4 to the power of n. Okay. Like 4 to the power of minus 1 into 1, n. Okay. So 4 power minus 1 is 1 by 4 to the power of n. So I have got it in this desired form to further solve it. So it's in the form of alpha to the power of n with summation limits 0 to infinity. So I can put 1 by 1 minus alpha and get the energy. Clear, everyone? Is it clear?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Now we'll try to solve a problem. Calculate total energy of the signal.
Excuse me, ma'am.
Yes, tell me.
Ma'am, in this even they've asked to find the power now, ma'am. Therefore, power remains 0 in this.
Power will be 0. Okay.
Okay, ma'am.
If energy is in energy signal, power will be 0. In power signal, energy will be infinite.
Okay, ma'am.
Yeah, power, put it 0. And you have a signal. This is your given signal. Okay. So the amplitude of this is +4 and -4. So the signal here is t is equal to 2, 4 and 6. This is the given signal. What type of signal is this? It's continuous time or discrete time?
Continuous and periodic.
Continuous.
It's continuous. No, is it repeating itself? It's not repeating. Only this much. It's existing from 0 to 6. That's all. It's periodic. A signal
No,
is periodic if it repeats itself at equal intervals of time. But only this much is our signal from 0 to 6. That's all. A signal will be periodic if it repeats itself at equal intervals of time from -infinity to infinity. But this is existing only from 0 to 6. Is it periodic?
no,
It's
ma'am.
non-periodic, okay? Because it's existing only from 0 to 6. So what we have to find? We have to find the energy because they have given already find energy of the signal. It's non-periodic, so find energy. What is the equation of energy for continuous time signals?
Integration of
Integral
minus infinity to
-infinity to infinity x of t square.
Modulus of x of t
X of
square
t
into
square.
dt. Okay. So my signal is existing from 0 to 6. Okay. So how do I write this? I will take from -infinity to 0. What is my signal? It is 0. 0 square into dt plus from 0 to 2. I have amplitude of, what is amplitude here?
-4, ma'am.
Yeah, so it will be -4 whole square into dt plus 2 to 4. What is the amplitude?
4.
It's 4, right? So 4 square into dt plus 4 to 6. What is the amplitude? -4. -4 whole square into dt. Now try solving this and tell me how much is the energy. Try solving this.
Ma'am, 96.
96. Check once. Or you can write one more term plus integral 6 to infinity 0 square into dt. So what is the energy? So this term will be 0 and this term will be 0. So you have, here you have, yes,
92, ma'am.
96 you will get, right? Check how you got 92. So energy is nothing but, so I have integral 0 to 2 16 into dt plus 2 to 4 16 into dt plus 4 to 6 16 into dt. Okay, so if you integrate 16, what do you get? You get 16t, right? Then put limits to t, 0 to 2, upper limit and lower limit.
Ma'am, 96, ma'am.
Yeah, so you have 16t with limits 0 to 2 plus 16t with limits 2 to 4 plus 16t with limits 4 to 6. Now upper limit minus lower limit you do. 2 minus 0 plus 16 into 4 minus 2 plus 16 into 6 minus 4. So you have 16 into 2 plus 16 into 2 plus 16 into 2. How much you get? 96 joules. Clear? What is the average power of this? Power of the signal? It will be 0 because it's energy signal, power will be 0. Clear everyone?
Yes, ma'am.
So they're asking you to find the energy of this signal. The signal is existing from 0 to 6, okay, with amplitude +4 and -4 accordingly, okay. So we'll take energy is equal to integration -infinity to infinity x of t square into dt. So from -infinity to 0, you don't have any signal. So I've written 0 square into dt plus from 0 to 2, from t 0 to 2, you have amplitude -4. So -4 square into dt plus from 2 to 4, you have amplitude 4. So it's 4 square into dt plus from 4 to 6, you have amplitude -4 square, -4. So -4 square into dt plus from 6 to infinity, there is no signal. Okay, so 0 square into dt. So this first term and last term will be 0. So you have 0 to 2, 16 into dt plus 2 to 4, 16 into dt plus 4 to 6, 16 into dt. So if you integrate, you get t. So put upper limit minus lower limit and you'll get the energy of the given waveform. Clear everyone?
Yes, ma'am.
So I'll give you one more signal. X of t is equal to e power minus at into u of t. Try this where a is greater than 0. So how will the signal look? How will the signal look? So it will be a decreasing exponential signal, right? It will be something like this. So it's non-periodic signal, so you find energy of the signal. Okay, so what is the equation for energy? -infinity to infinity modulus of x of t whole square into dt. So you have u of t also. So u
Ma'am,
of t means,
exponential is non-periodic, ma'am.
yes, exponential is non-periodic signal. Will it repeat at equal intervals of time? No, right? The amplitude will be diminishing or increasing. For increasing exponential, amplitude will be increasing. For
Ma'am, but
diminishing, it will be decreasing.
Ma'am, it will increase at a constant rate, right? An exponential.
Is the amplitude same?
Oh,
No, right? So it will be diminishing. So it's non-periodic. So u of t means the signal will exist from 0 to infinity with an amplitude 1. Okay, so our signal will be 0 to infinity e power minus at into 1 whole square into dt. So try solving this. What do you get? So 0 to infinity, you have e power minus 2 at into dt. So what is the integration of e power minus at? e power minus at will be e power minus at divided by minus a, right? So what do you get here? E power minus 2at by minus 2, correct? So minus 2a. So you have e power minus 2at by minus 2, limits 0 to infinity. So wherever you have t, put the limits 0 to infinity. Upper limit minus lower limit. So you take minus 1 by 2a other side, like it's a constant, and put limits to this e power minus 2at t, okay, which is nothing but minus 1 by 2a into e power minus 2 into a into t infinity would be infinity minus e power minus 0. So what you get? 1 by 2a, sorry, 1 by minus 2a into minus 1, correct? Because e power infinity will be 0 and this would be 1. So you get 1 by 2a joules. This is energy, so we take joules. What is the power for this? Power is 0. Clear, everyone?
Yes, ma'am.
Clear, everyone? Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. So we'll solve one power signal now. So find the power of the signal. So this is my waveform. This is x of t, and you have a signal like this. It goes on up to infinity. And this goes on up to minus infinity. So it's a periodic signal with amplitude A0, and the time period here is T0 by 2, and here it is minus T0 by 2. So try to find the power of this. What is the equation for power?
1 by t integral 0 to t
1
modulus
by
of
t integral 0 to t, or we can take one time period we have taken like this. We can take minus t by 2 to plus t by 2. Okay. So I'll take it from minus t by 2 to plus t by 2. You can take anyway, okay? You can take from minus t by 2 from here to here, or from here to here you can take. Okay, so this would be t by minus t by 2, this is plus t by 2. So we have one time period t. So power is nothing but 1 by t integral minus t by 2 to plus t by 2 x of t modulus of x of t whole square into dt. So now try finding the power of this signal. So power is nothing but 1 by t. So from integral minus t by 2 to 0, what is the amplitude of the signal?
A0, ma'am.
From minus t by 2 to 0. Here.
it's 0.
It is 0, right? You don't have any amplitude here. The signal amplitude is 0. So it's 0 square into dt plus 0 to t by 2. What's the amplitude?
A0.
A not
A0. So it's A0 square into dt. So if you integrate, what do you get? So P is equal to A naught square by T into integral 0 to T by 2 1 into dt. So if you integrate that, you get T. So A naught square by T A naught square by T into T with limits 0 to T by 2.
Hold on, ma'am, little.
Yeah. So power is equal to A naught square by T into T by 2. Correct? So T and T gets cancelled. So power is A naught square by 2 watts. So what is energy of this signal, of this periodic waveform?
Infinity, ma'am.
It's infinity. Okay, energy is infinity, power is finite. Clear, everyone? Is it clear? You have
Yes,
any
ma'am.
doubts?
Yes, ma'am.
So we'll find the power of sine wave. So take down, find the power of x of t is equal to a naught sine omega naught t. So try to find the power of this signal. So the equation of power is 1 by t integral minus t by 2 to t by 2 x of t modulus of x of t whole square into dt.
We can take 0 to t also, limits.
Yeah, you can take 0 to t also or minus t by 2 to t by 2 also. One period you have to take. So I get 1 by t limits minus t by 2 to t by 2. We have a naught into sine omega naught t whole square. Okay, so it's a naught square into sine square omega naught t into dt. So a naught square is a constant, take it to the other side. So you have a naught square by t integration minus t by 2 to t by 2 sine square omega naught t into dt. So sine square theta, how can we write sine square theta? 1 minus cos 2 theta by 2. So take it in this form. Okay, so if you take it in that form, we'll get a naught square by t limits minus t by 2 to t by 2. You get 1 minus cos 2 omega naught t divided by 2 into dt. Okay, now we can split this term or this function and integrate. So you have a naught square by t integration limits minus t by 2 to t by 2 1 into dt minus integration limits minus t by 2 to t by 2 cos 2 omega naught. I'll take 2 outside here. Okay, so cos 2 omega naught t into dt. So what is the integration of cos?
0, ma'am.
It will be 0, so no need to
0.
integrate. So it will be 0. So you have a naught square by 2t into t with limits minus t by 2 to t by 2. If you integrate one, you get t with limits minus t by 2 to t by 2. So what do you get? So it's a naught square by 2t into t by 2 plus t by 2, right? So you get t, so it's a naught square by 2t into t, so that would be a naught square by 2. Clear, everyone? Watts. Clear?
Yes, ma'am.
So the power of our sine waveform is a naught square by 2. So we had solved cosine waveform also. What was the power of that? You remember we had done yesterday cosine waveform?
A squared by 2, ma'am.
Same, right? It is the same.
Yes, ma'am.
Amplitude square by 2. Clear?
Yes, ma'am.
So I'll give you one problem with sine and cos, and I will solve non-periodic signals also to find power. That unit step I had told you yesterday, I'll solve that. So this you can see by telling only, find the power of phi cos 10t plus phi plus 10 sine phi t plus phi. So what is the power of this signal? This is a composite signal, just for your reference, for example. So this is the first part and this is the second part. So what is the power of cosine waveform?
A square by 2.
So I'll take it as PA, power of this, and this I'll take it as PB. So PA is nothing but cosine waveform, right? So it is a square by 2 or a naught square by 2. So what is the amplitude of this cosine waveform?
A square by 2, ma'am.
Yeah, what is the amplitude?
5.
Phi square by 2. So this is the power of this first part of the signal. So next, for sine, you have PB, which is nothing but a square by 2 only, right? For sine waveform also, the power will be amplitude square by 2. So what do you get here?
$50, ma'am.
10 square by 2, right? So 25 by 2 is 12.5 watts and 100 by 2 is 50 watts. So total power of the signal is PA plus PB, which is nothing but 12.5 plus 50, it's nothing but 62.5 watts. Clear? Are you guys following?
Yes, ma'am.
Okay, so we have seen some power signals and energy signals. So that I told you there is an exceptional case. So we have one unit step signal. Okay, so we shall find the power of unit step. Unit step is a non-periodic signal. So we shall find the power of that non-periodic signal, u of t. Okay, so given the question, so find the power of the given waveform. So take down the waveform. You have x of t, okay, and so you have x of t, and the signal is something like this. it is 0. And at t is equal to 0, it is like this. Okay, so it goes on up to infinity. So this is time axis t. And what is a period? How do you take the amplitude is a naught? So how will you take the period for this? I'll take from minus t by 2 to plus t by 2. Okay. So could anyone tell me the power equation for non-periodic signal, continuous time?
Limit
P is equal to limit t tends to infinity
1 by t
1 by
integral
t integral minus t
minus
by 2
t
to t by
by
2
2.
modulus
Modulus
of
of
x of t square into dt.
Yes, ma'am.
Correct? So now we'll try to solve this. Okay, this is a unit step signal, as you people know. So now we have to find the power of the given waveform. So P is equal to limit t tends to infinity. So I have 1 by t and I have a waveform x of t. Okay. So as you can see, from minus t by 2 to 0, the amplitude is 0. Correct? So minus t by 2 to 0, the amplitude is 0. So I have 0 square into dt plus from 0 to t by 2, I have amplitude a naught. Plus 0 to t by 2, my amplitude is a naught, so a naught square into dt. Okay, so now what do you get? How do you solve this? So limit t tends to infinity, you have a naught square by t. So if you integrate 1, what do you get? You get t from limit 0 to t by 2. So what is the power? Put upper limit minus lower limit and find out the power. So P is equal to limit t tends to infinity. You have a naught square by t into t by 2 minus 0. So what you have? So power is nothing but a naught square by 2. Clear? So power of unit step signal is nothing but a naught square by 2. Is it clear, everyone?
Yes, ma'am.
So I'll just give you an example. Find the power of this signal x of t. So this is minus 1, amplitude is 4, and this goes on up to infinity. So how do you find power? So split this waveform. Okay, I'll split it as xa of t and xb of t. So my xa of t is a signal from minus 1 to 4, sorry, minus 1 to 0 with amplitude 4, and xb of t is a unit step from 4 up to infinity. So what is the power of this signal? xa of t.
Ma'am, A not A.
What is
4
x?
square by 2 it, ma'am.
No, what type of signal is this? It's energy signal, right?
Yes, ma'am.
This is energy signal, so power is 0. And what about this? This is a unit step, right? What is the power of unit step? A naught square by 2 or 4 square by 2, right?
Yes, ma'am.
What do you get?
8.
8. So the power of this x of t signal is 8 watts. Clear? Is it clear, everyone?
Yes, ma'am.
Energy and power signals. So, 1 minute, I'll give you unit step in discrete form. You try solving that. Oh, we have time, right? 2 more minutes. I'll only solve that. So, yeah, find the power of this signal. Find the power of x of n, which is equal to u of n. So, what is u of n? It is a unit step. So, a signal u of n exists from 0 up to infinity with an amplitude 1, right? N 1, 2, 3, 4 up to infinity with an amplitude 1. So this is a non-periodic signal and you have to find power of non-periodic signal. So what is the equation for that? Power of discrete time non-periodic signal. What is the equation? Limit n tends to infinity. Tell me the equation.
Ma'am, limit n tends to infinity 1 by 2n plus 1
1 by 2n plus 1
summation n is equal to minus n to n
minus n to n.
modulus of x of n whole square.
Clear, everyone? This is the equation for power for non-periodic discrete time signal. Okay. So our signal will exist from 0 to infinity, right? So we'll try solving this. So I have limit n tends to infinity 1 by 2n plus 1 and I have summation from n is equal to 0 up to capital N. Okay, I have 0 to n into x of n whole square. So what is x of n? The amplitude of x of n is 1, right? From 0 to n. So I have limit n tends to infinity 1 by 2n plus 1 into summation n is equal to 0 to n 1 square. So what is the what do you get? 0 summation 0 to n 1 square. What do you get? How can you summarize that? So if I take summation n is equal to 0 to 2 1, what will you get? That means the
2
signal is existing from 0 to 2, 0, 1, 2, right? So what is what is n now? So what do you get? Sum from 0 to 2. You get
1,
3. 3, right? You have a signal here. You have a signal here. You have a signal here. At 0, you have amplitude 1. At 1, you have amplitude 1. At 2, also you have amplitude 1. If I sum 1 plus 1 plus 1, I'll get 3. Correct? So I have from 0 to n. What would that be? 0 to n.
n plus 1.
It will be n plus 1. Correct? So if I add 1 plus 1 plus 1. Okay, 1 minute. 1 plus 1 plus 1 up to n, I'll get n plus 1 because from 0 to n, summation n is equal to 0 to n, I'm getting n plus 1. That is 0 to 2, I have 2 plus 1, 3. Suppose it's 0 to n, I'll have n plus 1. Okay, so I'll take it as limit n tends to infinity n plus 1 by 2n plus 1. Okay. So now
Ma'am, summation of 1 is only 1, no, ma'am.
summation from n is equal to 0 to n. You have to add all the ones from 0 to n.
There is no variable n, ma'am, to substitute from 0 to n.
Where? 1 minute. I'll show the waveform and explain you. See, if you have 3 samples with amplitude 1 from 0 to 2, what is the summation? You get 3, right? The sum, what is the sum you get? You get 3. Similarly, if you have from 0 to n signals, all ones you have, samples 1. So if you add that, you'll get n plus 1 only, right? Yes or no?
Yes, ma'am.
So we have limit n tends to infinity, n plus 1 by 2n plus 1. So I'll take limit n tends to infinity. I'll take n common in both. If I take n common, so I have 1 plus 1 by n divided by, I take again n common, I have 2 plus 1 by n. Sorry. 2 plus 1 by n. So my n and n will get cancelled. So if limit n tends to infinity, substitute n as infinity in numerator and denominator. What do you get? So I have limit n tends to infinity, 1 plus, so I have 1 here, right? 1 plus 1 by infinity divided by 2 plus 1 by infinity. What do you get? 1 plus 0 by 2 plus 0, which is nothing but half watt. Clear? Is it clear, guys?
Yes, ma'am.
Understood? Energy and power. Just a minute, this is not responding. Yeah, they have asked you to find the power of unit step, and this unit step signal has samples. Okay, and from 0 to infinity, the amplitude of each sample is 1. Okay, this is our unit step signal. So we have to find the power of a non-periodic signal. So this comes under non-periodic signal, and we have to find, it goes up to infinity. Okay, it doesn't converge to a finite value. Okay, so we have power P is equal to limit n tends to infinity 1 by 2n plus 1 into summation n is equal to minus n to n x of n whole square. So we don't have signal this side, left side, we have only right side because it's unit step signal. So I'll take summation limits from 0 to n only. Okay, so and x of n amplitude is 1. So we have n limit n tends to infinity 1 by 2n plus 1 summation 0 to n 1 square. Okay, so how can we write this summation 0 to n 1 square? So suppose if you have a signal from 0 to 2, I can add it 1 plus 1 plus 1, 3 I'll get. 1 here I have sample 1 at 0. So 1 plus at 1 also have 1 amplitude 1, at 2 also have amplitude 1. I can add this finite values. So n, I don't know what is n from till where it goes. So I can write it as n plus 1. Okay. So limit n tends to infinity n plus 1 by 2n plus 1. So if I take n common in both numerator and denominator, I can cancel it out. So I have 1 plus 1 by n by 2 plus 1 by n. Okay, so if n tends to infinity, I can take n value as infinity here, so that you will get half watt. The power of this signal, discrete time unit step signal, is half watt. And what about energy? Energy of this signal, it will be infinity. Clear?
Yes, ma'am.
Is it clear, guys?
Ma'am,
Energy
can
and
you
power.
scroll a little bit down now?
Yeah. Just a minute. This whiteboard is not responding. Yeah. Visible?
Yes, ma'am.
So I'm left with even and odd problems on discrete time signal, right? I will solve that in coming classes. Okay. You have any doubts? Is it clear? Everyone?
Yes, ma'am.
Clear?
Yes, ma'am.
You can write your name and USN in the chat box for attendance purpose. So tomorrow we shall see about discrete and even and odd signal problems. Not tomorrow, next class. Tomorrow I don't have class, right? So next I have a class on Monday. So Monday we shall see about even and odd signals, discrete time signals, and I'll explain you elementary signals. Okay, unit step, unit ramp, and on in detail. We shall wind up this class. Thank you, students.
Ma'am,
Yes, Abhishek.
ma'am, you got that Ganesh Rao thing, ma'am.
I have
Hello,
the textbook. I am not finding time to scan and send you. I'll scan and send you because I'll be having classes, okay, first half of the day. Next half, I'll be have to go for exam duties. So I'm busy. I'll send you. I'll scan and
Fine.
send you. Ganesh Rao and Uday Kumar, I'll send you both.
Okay, fine.
I'm giving Google Classroom.
Okay, ma'am. Fine.
Yes, Maithili?
Ma'am, send the recordings also, ma'am.
Yeah, I'll post the recordings also.
Thank you.
Yeah.
Ma'am, in Google Classroom only you can send the Ganesh Rao.
Yeah, I'll post
PDF.
it there only.
Fine.
Okay? Yeah.
Thank you.